Hello guys, today we'll be solving reverse bits Leetcode problem, and as you can see, the problem is pretty similar to the number of 1 bits problem that we solved before. We have the same node for the Java programming language, and the only different part is actually the problem statement, which says that we have to reverse bits of a given 32 bits unsigned integer. And as you can see, the constraints are that the input must be a binary string of length 32. And in the examples, we have basically just a binary string, which is, and you see we also have the real value when converted to the base 10. And also we see that the number has just been reversed. So we have zeros, like 6 zeros here, 6 zeros here, and then 1, and then 0, 1, and yeah, it's basically from input is left to right, and the result will be right to left. The same goes for this example. It might be easier to notice the change because we only have 1 0, and that 0 will be at the second place from left, reading from left. So in this in original input, it was next to the last bit, but now it's next to the most significant bit, the first bit, and the rest of the ones are just in the same order as we had before. Our last problem, the number of 1 bits, we already know how we can get the last bit. So for example, if we have a binary representation like this, if we if you use the operand end, the second operand being 1, we will just get the last bit. All the other bits will be cancelled out, and the result will be 0 for all the other bits except for the last bit if it's 1. If it's 0, then 0 and 1 will always result to 0. Now we know how to get the last element, and we know also how to shift with this logical shift to the right. So if we shift by 1 place from this number, we will get this number. So we will insert 1, 1, 0 in front of the number and just move in front of the binary representation and move it to the right. So if we have our input number like this, we know how to get. So we can break the problem into three steps. Get the last bit, shift it to the correct position in the reverse representation. And maybe this is not the same and the best example because it's a palindrome, as you can see. So I'll just do a 1 here. And so if we do if you get the last bit, we just want to shift it to the first position. Now here it's in the last position. How can we shift it? We can, because we know it's like we will have a binary representation of 32. So the length of 32. This one is just example, it's length of 5, but you can just pad it with zeros, enough zeros, and then reverse it. But just for the explanatory purposes, it will use the length of 5. So if we can have a mask, and it's just a number that says how many places we will shift to the left, the bit. So if we can shift the bit, if you can start with our result will be 0, that's the neutral element. And if we can get the bit, so this bit is currently 1, and use the mask, we can use kind of like a reverse operation of this. We'll shift to the left by several positions, like in this example 4. If you do that, we will place 1, that's the bit, and then insert as many zeros as we have the value of mask. So we have 4, so it will be 4 zeros. So, and then after that, we can just decrement the mask. So the next will be 3. And when we get the next bit, which will be this, because we will apply this operator, and we will end up with a number looking like this. So our next bit is, again, the number 1, and we will shift it with 3 positions. So it will go here. will just have the same. We will just copy over the 3 remaining zeros. But how do we concatenate? How do we merge each of the bits? To do that, we use OR operator. You will see it oftentimes represented by a pipe. So the OR operator has the following properties. So if we have operands A and B, and if I use A or B, and we will have the following bits 0 and 0, 0 and 1, 1 and 0, and 0, 1, 1 and 1. And the result will be for 0 and 0, and it will be 0. And for the rest of it, it will be 1, 1. So you only need one operand to be non-zero, to be 1. And if you do a concatenation with the mask, you will have something like this. So let's say this is the number that we got by applying the first mask. The next mask will be 3. So we will have this representation. We'll have 3 zeros and then 1 because it's shifted by 3 times. And now, how do we merge these numbers? So if you use the concatenator, the OR operand, we will have 0 and 0, 0, 0, 0, because that's our first row here. And then for 1 and 0, it will be 1, and for 1 and you can place a 0 here, it will be 1. So you're basically merging these two ones into one number. And until you basically proceed with this until you get to 0 in your for loop for our original number. And then you basically place all the bits in reverse order in your resulting reverse binary representation. Code up the solution. We'll first start by declaring our result as 0. And our mask, our initial value for the mask will be 31 because we want to target the last bit. And to target the last bit, actually that would be the first bit in the reverse binary representation. To target it, we have to shift by 31 place because 32nd place will be actually the bit that we want to set. Next, we will, just as we had in the number 1 bits problem, we will iterate until we converge to 0. And each time we will first get the current bit that we have for our initial input, and then we will shift it by the current value of mask and concatenate it to our result with the OR operator. And we'll proceed basically doing that until we converge to 0 with our original input value. And to converge to 0, we will always just shift to the right by 1, so to get the next bit. And because we want to now target not the first position in the reverse representation, but the second, we will reduce the mask. At the end, we will just return the result. Because we are operating on limited size, like binary representation 32, and we have limited size of integer that it can grow, we have a limited time, constant time and space complexity for this problem.